Hello everyone, in this video we are going to see the solver for a ordinary differential equation in a Python. So we are going to solve this equation, solve dy by dx equal to x minus y, where x0 equal to 0, xn equal to 0.4 and y0 equal to 1. In this we are going to find out the value of yn at xn equal to 0.4. So let us see the solver in a Python. So the first statement start with a hash. Solver for a ODE in a Python means what? It is a comment. So import numpy as np, then from scipy dot integrate import sol underscore ivp. So sol underscore ivp is the solver which we are going to use. Then we need to define a function, that is def f of x comma y colon. In written we need to write a function, that is x minus y. Then we need to create an array of x0. So x0 equal to np dot array. So that's why import n numpy as np we have included. So x0 equal to np dot array in round bracket, then in square bracket 0 comma 0.4. Now 0 represent the initial value of x and 0.4 represent the final value of x. Then we are going to write the array of y0, which is np array, in bracket 1. So 1 is nothing but a value of y0, and we need to find out the value of yn. So here in statement 8, yn equal to sol underscore ivp in a bracket f comma x0 comma y0. F represent a function, x0 represent initial value and y0 represent the initial value of y. So print yn. So after this we are going to run. So on a console side you can see the answer lies 0.74064067. So this is the answer which we have got from this solver ordinary differential equation, solver of an ordinary differential equation in Python. Now you can cross verify this answer by solving analytically. So I'm writing here the answer is 0.4064067. So this is the final answer which you have got from the solver, from the ordinary differential equation solver. Thank you all for watching this video.